In today's video, we'll cover everything you will need to know about ortho, meta, and para directors in aromatic compounds. So first, there are ortho and para directors, and usually para will be the slightly more major product because of less steric hindrance. And these directors have activators, which are faster reactions, and deactivators, which are the halogens, chlorine, bromine. Now the activators typically have some sort of lone pair on it, so that usually looks like an oxygen or a nitrogen bonded to the benzene, or an alkyl group, which is a hydrocarbon, but there can be other non-hydrocarbon things on the other side of a hydrocarbon, but we'll get to that in a bit. Essentially, these activators, ortho para activators, they have O, N, or an alkyl bonded to the benzene, and one thing that distinguishes them from the meta deactivators is that although your deactivators typically have a positive electronegativity due to highly electronegative things bonded around it, okay, that's usually the case. However, you might get something that's nitrogen bonded to two oxygens, so then you might think, hey, it's nitrogen, that must mean it is an ortho and para director. But because this has a positive electronegativity and it has a positive formal charge as well, actually, in that case, this NO2 would be a meta director. Okay, so the biggest thing that helps me distinguish between ortho, para, meta is the meta ones typically have highly electronegative atoms surrounding the molecule bonded to the benzene, and usually there are double bonds around these molecules as well. So there is typically a list that you would usually want to memorize, but the rule that I just talked about is pretty consistent. So to recap, meta directors have usually double bonds around it and electronegative atoms surrounding it, whereas usually O and N and alkyls are ortho-paras directors. Okay, let's try some problems. When you have a benzene, there are two substituents on it. Typically, the substituent, that is the activator or the stronger activator, will win out. So that one will trump. That one will determine where the thing you're trying to add goes on the benzene ring. Okay, so in the case if you have two deactivators, then you would compare which one is less deactivating or which one is more activating out of your groups. So let's try this example. COOH, double bonds, and also highly electronegative atoms withdrawing electron density from carbon. That means this is a meta director, so we would expect here. However, chlorine is an ortho-para director. Now, because hopefully your textbook has this table as well, this is more deactivating than the halogens. So because halogen, even though it's a deactivator, it's more activating than COOH. Therefore, the position of our NO, our neutral group, is gonna be determined by this. So ortho could be here. This is one possibility, or another possibility could be para. Now, we do not put things in the middle of two groups, whether that be for an ortho or a meta position. We do not put a group in between two substituents because of steric hindrance. Okay. Now for this example, we want to add this group on the benzene, but we have two benzenes, so which one should we add it on? First, if we think about this benzene, we have a meta director, and if we put it on this benzene, we have an ortho-para director because this is an alkyl group, okay? Although, yes, there's a carbonyl on the left of this alkyl group, nonetheless, the molecule attached to a benzene itself is a hydrocarbon. It is an alkyl group, which means this is ortho and para, and it's more activating than your carbonyl, okay, because of the electron density. So this is an activator, this is a deactivator, and the activator wins out. Therefore, our substituent is going to go on this benzene ring, and it can go on ortho position or para position. Okay, and this would be the chlorine that would be substituted there. That was there, but now it's attached to the benzene, and then we have 2 carbons. So I hope this video was helpful. If it is, make sure to hit a like and subscribe.